this lesson, we deepen our understanding of ratio and proportion by using them in a new context, estimating how many fish are in a lake. We also review how to use percentages with proportions. Wildlife biologists use a method called capture-recapture to estimate how many fish are in a lake. This method involves catching some fish, tagging these fish, then releasing them back into the lake. Later, they go back to the lake, catch some more fish, and count how many of them are tagged. They can use this information to estimate how many fish there are in the lake. We're wondering how many fish there are in this pond. On our first trip to the lake, we catch and tag 30 fish. The red fish represent the fish that we tagged. When we return for our second sample, we catch 20 fish. Remember, we are trying to use this information to estimate the total number of fish in the pond. We don't know how many total fish there are. But what we do know is that of the 20 fish we caught, 3 of them were tagged. We're trying to figure out the total fish in the pond. We can set up a proportion where x represents the total fish in the pond. Solving for x, we estimate that there are about 200 fish in the pond. We can describe the results of capture-recapture situations using percents. Here's an example. In a lake with 350 tagged fish, biologists find that 16% of the fish in their catch are tagged. About how many fish are in the lake? We write the proportion. 16% can be written as a ratio of 16 to 100 because percent means per 100. We know that there are 350 tagged fish, but we don't know how many total fish there are in the lake. We'll put our variable in the denominator because that's where our total goes. So 16 is to 100, as 350 is to the total number of fish in the lake. X is in the denominator, so we invert the proportion. Multiply both sides by 350, and simplify. $350 times 100 divided by 16 equals 2,200. There are about 2,200 fish in the lake. When you have a word problem, don't forget to write your answer as a sentence. Here's one for you to try. Approximately 18% of the U.S. population is school age. One county reports they have about 30,000 students in all their schools. What is the total population of the county? So once again, what we don't know is the total population. So our variable will go in the denominator. And here's the solution. Feel free to hit the pause button. We can use proportions with percents in many situations, but we have to be careful when we set them up. Here are a couple of examples. 13 is what percent of 45? Let's use proportions to solve this problem. First, we'll set up the proportion. We see that this is a percent problem. Percent means per 100. So we know the 100 will go in the denominator. Now what we don't know is the percent. So in this case, our variable will go above the 100 because we don't know the percent. With proportions, we put the total in the bottom, and 45 is our total. And so we fill in 13 above the 45. Letter B. What number is 32% of 120? First, we'll set up our proportion. This is a percent problem. Percent means per 100 again, so we put 100 in the denominator. This time we do know the percent. 32% is the same as 32 over 100. 120 is the total because we're wondering what number is 32% of 120. So this time what we don't know is what part of 120 are we looking for. Here's one for you to try. 52% of what number is 63? And here's the proportion. Notice what we didn't know this time was the total, so our variable ended up in the denominator. In this lesson, we used proportions to make estimates and work with percents.